In this video we're going to look at some problem solving involving surface area. We can see a shape here. This solid is to depict a greenhouse. You've probably seen them before, greenhouse. They're used in gardens and nurseries where they grow plants and stuff like that. So you can see the picture, it's got some dimensions on it. Now we have to work out how much shade cloth. Okay, so shade cloth, you probably know that it's that semi see-through nylon stuff, and it has a wooden door there. Okay, it's dimensions of 1.2 times 1.5. Notice that it is a wooden door. Shade cloth is not wood. Okay, so let's go through our problem solving processes. We have to do two things in this problem. We have to find the total area of shade cloth needed to completely cover the greenhouse, and we have to find the cost of the shade cloth, and the unit cost is $6.50 per square metre. So remember, today we're doing surface area. We've been doing some work on volume lately. This is surface area. So our steps are predict, clarify, solve, reflect. Well, what are we going to do? We've got a composite shape. So composite solid or composite shape, and that means it has more than one solid, and we're going to be adding or taking areas to get the total surface area of different shapes. Alright, so clarify. Let's see, I understand all of the terms used there, so I don't need to look any words up. What have we been given? We've been given three shapes. Okay, we have a rectangular prism. If you have a look over here, rectangular prism. What else do we have there? We've got this dome shape on the top here on the roof. Well, that appears to be, I'm going to assume that that is a half of a cylinder, or a semi-cylinder, I'm going to call that, because it's half. So semi-cylinder. That's a bit of an assumption because you don't know if it is exactly a half or if it's close, but I'm going to assume that because we don't have any further information, so it's reasonable to assume that. And what else do we have here? We have a wooden door. Now the wooden door, I'm pretty safe in assuming that that's not going to have any shade cloth on it. So the door is a rectangle. Okay, it's a rectangular area which will then affect the surface area. Okay, so let's scroll a bit there. So I think I'm ready to start now. I'm going to look at the total surface area. So we've got the shapes listed there and clarify. We've got total surface area of the shape of the greenhouse is the surface area of rectangular prism with a few little changes I'll talk about in a minute. That's why there's an asterisk there, plus the surface area of the semi-cylinder, and I'm going to put a little hashtag on that because there's a little note I want to make about that, minus the area of the rectangular door. Let me pronounce that properly. I should just say rectangle there. Now, I said I'd make some notes about a couple of these things. A little asterisk here. We got the surface area of a rectangular prism. So there's a few things there. Surface area is the area exposed to the outside world, I suppose, in this case. So we don't have the top, as far as we can tell, there's nothing exposed to the outside there. There's not going to be any shade cloth there. And on the bottom, underneath on the ground, we're assuming also there's no shade cloth on the dirt, on the soil. Okay, there might be something else there like the bare earth or gravel. Okay, so I've assumed that as well. So we have a front, a back, a left and a right, but not a top and a bottom. So we have basically two lots of this one, and we have two lots of the opposite one, then we have two lots of the front and the back, and that's it. We have four sides. So we could write a fancy formula out. I think in this question, to keep the video short, I'll just put the dimensions in for now. So we've got length times the height for this long side. So let's make that a little bit cleaner. I just basically clean that up there. So we're looking at that side and inside there, which you have to be around the other side to see it. That side times that side. So they're rectangles and they're 5 times 2.5. So we have two of them, two lots of 5 times 2.5. And then the front and the back, which that's in green there. There's one at the back, it's hidden detail there. And we have two of them. 2 times 3 by 2.5. Alright, so that there is the first bit. We've got the prism. Now we need to work on the semi-cylinder, the surface area. This one will require a bit of thought. Now we've got the hashtag part here. Alright, that's what we're looking at. Some notes here. If you look at that cylinder, it's not a regular cylinder. It's actually got half of the surface area of a regular cylinder. Now this is going back a little bit, but we looked at the surface area of the cylinder is going to be basically half of 2 pi r squared, two circles, plus 2 pi r h. So I'm going to change that into some numbers. You might want to get these notes there, but 2 pi r squared plus 2 pi r h, remember two circles plus the tube bit. That's the two circles plus the tube bit. We've only got half of that, haven't we? It's cut in half. So in fact we've got half of the tube bit and half of two circles, which is one circle, isn't it? So I'm going to delete these symbols. You might want to put them in your notes, but I'm going to delete these. So putting in the actual numbers, 2 times pi times, what's the radius? Well, it's 3 meters right across, so it's 3 meters along there, and that would be the diameter of a circle. It's a semicircle, same thing. So half of 3 is 1.5, so it's 1.5 is r, so it's 1.5 squared for r squared, times the h. The cylinder goes along there and its major axis, so it's that length, which is 5. So times 5, change my colour, so 2 pi r squared, actually sorry, forget that bit just about the height. I'm doing the next part before I'm doing the first part. So it's just 2 pi r squared, which is two circles, but we're halving that out the front. That's the circular bit, and 2 pi r h from our previous work is the tube bit. So 2 times pi times r, remember, is 1.5. Now we times it by the h, which is 5 meters. Alright, so remember 2 pi r squared is the two circles and 2 pi r h is the tube bit which can open up to become a rectangle. You might remember that from our previous work. Now for the door, we've got the door is 1.2 by 0.5, so we need to subtract that. Because it's a rectangle, it's simply just length times width. A better solution to this would actually have the formula put in there, but I'm just trying to keep the video reasonably short. But it's time to calculate all this. So we've got 2 by 5 times 2.5 is 10 times 2.5, which is 25, plus we've got 2.5 times 3 is 7.5 times 2 is 15. So we've got 15 there. If we've got half times 2, they cancel out, and a half times 2, they cancel out. So we've got pi times 1.5 squared. So we can use a calculator if you like. Pi times 1.5, and we square the 1.5 equals, I get 7.07. And we've also got this part here, pi times 1.5 times 5, so pi times 1.5 times 5, 23.56. Okay, 23.56. And lastly, we've got the little rectangle there. That's half of 1.2, which is 0.6. Which is getting close to the end now. So we can subtract, that's 30.03. If you look at those two parts there, 30.03 plus 40 is 70.03 square meters, because it is a surface area. The last part is we had to find the cost of the shade cloth. If it's $6.50 per square meter, that's a rate, so we just multiply. Let's have a look. So at $6.50 per square meter, we have the cost is 70.03 times $6.50, or 6.5. 70.03 times 6.5, and we've got $455.20. $455.20 for the